Hey, thank you for joining us this week on the Scientific News Channel. This week we have a special guest with us. His name is Edward Morley. I don't think he needs much introduction, but why don't you go ahead and tell us a little about yourself and why you're here.
Thank you, Ted.
Well, as you heard, my name's Ed Morley. More than likely you know me from my work with the Michelson-Morley experiment. Thank you for joining us, Ed. Why don't you just go ahead and tell the audience here a little bit about your experiment and what were you guys hoping to find while you were doing it?
Absolutely. So, the way we understand sound is that it travels like a wave. Similar to how if you drop a stone in a pond, it creates a ripple effect, And the air that the sound travels through, or the water that the ripples travel through, are known as the medium. And we believe that light travels through a medium as well. This medium we call luminiferous ether. And with the experiment, we were hoping to prove that this ether exists. And the way we understand it is that it's a non-tangible thing. It's not something we can touch or see or act or do anything to. But we think that it travels like wind, and similar to wind here that we can feel it on our face. Depending on the direction of the wind, depends on how it acts on stuff. So if something's traveling with it, it speeds up. If something's traveling against it, it's going to slow down. You understand what I'm saying? And our hope is that by shooting a beam of light at a half-translucent mirror, which will allow some of the light to travel through and reflect some of the light at a 90-degree angle, we will let them travel in different directions, hit another mirror, and be reflected back, which then the opposite will occur, and it'll combine the beams of light back together. And depending on how those waves come back together, with how we understand waves to work, that if they don't return at exactly the same timing, the waves will have interference on each other, so they'll cancel each other out partially, if not completely. And if this occurs, then we can prove that light travels at different speeds in different directions, which in turn helps support the case that there is this luminiferous ether.
Oh, very nice.
So by using this beam of light and bouncing it around, you're able to determine if this theory on the ether is correct or not. That must require some extremely accurate measurements. Is this something that you did entirely by yourself?
No, actually I was working with the Prussian scientist by the name of Albert Michelson. And honestly, if it wasn't for his work and research on light and the invention of his interferometer, we never would have been able to make this experiment. But as the name suggests, the Michelson is the first part of that Michelson-Morley experiment.
Oh, okay. Well, then what was your part in this experiment?
Well, I think it was my work with chemistry that really caught Michelson's eye. My ability for precise experimentation with the atomic weight and the density of gases. As you had said earlier, this experiment required absolutely as precise measurements as we could possibly do in order to keep the validity of the experiment. And if I heard right, you were a professor at the Case Western Reserve University. Is that by chance where you guys conducted this experiment?
Yes, we did in fact conduct the experiment there at the university where I was working.
And we know that you were hoping to find this ether, prove its existence. But what pushed you guys to pursue this? Was there some kind of discovery that led up to you guys conducting these experiments, or what exactly inspired you guys to do this?
Well, Ted, that's a tricky question, because as scientists, our passion, everything we do is in the pursuit of knowledge and
bettering our understanding of the world around us. But, if we had to dial it down to one thing in particular, I'd say it would probably have to be Thomas Edison's incandescent light bulb. You know, by just a few years later, that light bulb became pretty much a common item in every household, and really I think it just spurred on the knowledge and the pursuit of this understanding of light along with everything else. There's something special about that, what you said about science. It's like a domino effect where one person's findings lay the groundwork for people to build off of that one thing for generations to come. And, I don't think there's another place in society where you really get to appreciate that building blocks kind of thing with other people's research and their findings and their discoveries, their theories. Now, as far as the results of the experiment, we know that you guys didn't or weren't able to prove the existence of this ether. But in spite of that, how did that affect your pursuit of this matter? I mean, did it discourage you at all? Or did it inspire you to work harder next time to do better? Well, really, that's just the way science is. Most of the time, we don't get stuff right on the first try. And it's like you said, I mean, everything's a building step, and every finding gets us one level closer, or one step closer, I guess I should say, to a better understanding of everything. And, I continued working on the experiment, as did other scientists, for years, even after this findings. But eventually, after us failing to prove that the ether existed, people started to believe that it wasn't a real thing, and it really changed everything we understood about really the universe, because what our findings were telling us is that light didn't need a medium to travel through. Such a fascinating story. Well, thanks for tuning in today, folks. That's all we have time for. Thank you for your time, Mr. Morley. Be sure to tune in with us Friday night as we have a special on Isaac Newton and his discoveries and what impacts they had. Thank you, and good night.